Yeah, okay. So two new features came to the standard library. One is a language feature, exception groups, and the other one is an addition to the async IO module. These are interrelated because async IO task group uses exception groups to raise multiple exceptions. The exception group feature answers to a need that we have actually had for a long time, but we haven't really addressed it before this. So when multiple concurrent operations are done and multiple exceptions are raised from them, then you are faced with a dilemma what to actually raise from that aggregate operation. So, for example, in async.io.gather, the first exception was raised and the rest were just chucked out. That's not really optimal. So some solutions started coming up. For example, Trio's multi-error. But for the first time, I think in any programming language that I know of, we now have a concept of an exception group. So multiple exceptions can be raised simultaneously. There's a new syntax in Python for catching those exceptions. We will soon see some practical examples of that. To that end, there are two new built-in exceptions, base exception group and exception group. The former is an exception class that inherits from base exception, and the latter inherits from exception. This is to distinguish between the two for code that only wishes to capture normal exceptions, so to speak, and not something like a keyboard interrupt and system exit. The second feature, task groups, more closely relates to structured concurrency. In my previous talk, I mentioned NEIO's exception task groups, which are basically the same as Trio's nurseries. That is, it's a construct that allows you to spawn multiple tasks and then aggregate them together so that they either fail or succeed all at once. If any one of them fails, then they all fail. So async.io has had some mechanism previously for this purpose. Gather is one of them. Async.io.wait is another. But they have been suboptimal because usually they just wait if the first task succeeds and then chuck out the rest, or then wait for the first exception. Async.io.gather does have an option to return all of the raised exceptions, but normally you would want to do try or except to catch exceptions, yes, and not to iterate them. Like, this is not Golang. As I mentioned previously, the new task group raises any exceptions that are raised by the task in an exception group, regardless of how many exceptions are raised. Exception groups are currently used only in two places in the standard library. As I mentioned, there's a task group, but the other one is the socket.createConnection function. So to understand what happens there is that when you try to connect to an address, it may resolve to multiple IP addresses, so you need to try them in turn. And if multiple connection attempts fail, then you would want to retain all the exceptions that are raised by the different connection attempts to not lose information. There are some other places where it could have been used, but they couldn't due to API backwards compatibility. One is the concurrent Futurice package, which is a lost opportunity, sadly. Some third-party libraries make use of exception groups. It's still mostly work in progress. I'm not aware of very many libraries that have final releases that actually make use of exception groups. My own NEIO obviously supports them in the 4.0 branch. I have a PR pending on against Trio, which adds support for this, but it's currently bogged down in some requirements regarding backwards compatibility. And there's the hypothesis library. It's for testing against many different kind of scenarios. Hatfield Dodds has been very active in this development and has helped actually with the exception group backport library. I'll talk about that soon. Then just yesterday, JetBrains released an update to PyCharm, which now has support for the except star syntax. So that's great. But since Python 3.11's final release is still ways off, the tooling support is not yet all there. So if you want to learn more about how exception groups work in depth, you can see the PEP 654. But here's a short version of it. Instead of try except, you can have try and except star. And of course, as with try except, you can have multiple except clauses. The difference in semantics is that if you have multiple exceptions raised, then multiple blocks might actually be executed, unlike the first one in a normal try except block. Also, the exception object that you get in such a block, if you do except star the list of exceptions and as the object name, it will always be an exception group, no matter how many exceptions were raised. You cannot mix except star with except. It doesn't make sense. And even if you get even if you get multiple instances of the same exception type, each block will always only be run once. And return is not allowed because if it was, you might end up with multiple return statements being executed, and that also doesn't make sense. Let me show you some examples. Let's see if I can get it on this screen. Yes. No. Yes. Can everybody see this? Right. Now if I can just get the terminal open. Let me first show the code. And of course, I have the wrong window here. Sorry for the mess. Okay, this is the correct window. So in this first example, we will raise a simple exception group with 3 exceptions, a value error, a type error, and a 0 division error. And we have 2 Apologies. We have two blocks where I catch them. One is for value errors and type errors, and one for zero division errors. Let's see what happens. So it prints the type and the message of or the stringified form of the exception object. Here I'm just iterating over the exception group and printing each exception in turn. The second exception example, the second example is a bit different because I'm not raising an exception group, but rather iterating a list of exception objects. Okay, where did the terminal go? Here. And it prints the exact same thing. The third one. Sorry. The third one has one nested exception group. So this part will catch the nested one. Let's see what happens there. As you can see, the structure of the exception groups is maintained, so it doesn't unroll the exceptions. But the zero division error is raised the same way as before, so it's also handled the same way. Okay, that is for exception groups. So about task groups then. You use task groups with an async with an async context manager. And inside, you use group.createTask, just like you would use async.createTask, except that those tasks will now be part of this group, and the task will not outlive the group. So once execution reaches the end of that, Once execution reaches the end of that group, it will wait until all the tasks have finished. And if any of the tasks raises an unhandled exception, the rest of the task will be cancelled. And they will still be waited on. So they might actually raise multiple errors, which are then gathered in an exception group. So if any of the tasks raise an exception, it will raise an exception group out of the context manager. Let's see some examples. So this is the basic usage without any manufactured errors. We have one task function that takes an argument, and then we spawn two tasks with different arguments. Really simple. Yeah, not much to tell about this. In the second example, again, two tasks are spawned, but the second one will raise an exception. Now we get this fancy trace back. unhandled errors in a task group, and one sub-exception, which is the exception that we raised in that fail func here. Yes? Yes. It's the new standard. This is new in 3.11. Then I prepared the third example where multiple tasks fail. So first the fail func raises an exception, and then this first task will be cancelled, but there's a finally clause where it raises an exception of its own. So two exceptions are raised simultaneously. Crash and boom. Both exceptions are here. Now, some background for this. Task groups are not exactly new. To my knowledge, Curio, a lesser known I/O library, had them first. And then Trio, which was basically a fork of Curio, had got its own nursery class, and along with nurseries, they created this multi-error exception, which is a precursor for exception groups. Any I/O, which basically brings Trio functionality to async I/O, had its own task groups and also exception groups with those exact names. But HDB, in case you are not familiar with that, it's a project headed by Yuri Selivanov, the primary maintainer of async I/O. HDB had its own implementation of task group, quite a lot simpler than the one in Trio or any I/O. Then there are two other projects called Quattro and AIO tools with their own implementations of task group. I would say that Quattro's and AIO tools implementations are closer to a standard library than any I/O or Trio. I should note a few differences, crucial differences between the standard library task group and the implementation of Trio and any I/O. When you spawn a task in with the standard library task group, it gives you a task object that you can individually await on. Not so with Trio or any I/O. You don't get anything, you get none when you spawn a task. This is by design. Trio wanted to avoid anything resembling a future or callbacks. Whether that's ultimately good or bad, I don't know yet. Anyway, then the standard library doesn't have a concept of cancel scopes, which is basically a marked block where you can cancel a part of an operation. In any I/O and Trio, each task came with its own cancel scope, or rather the cancel scope belonged to the task group. So if you cancel that cancel scope, all the tasks inside it were also cancelled. A second important difference is that the standard library still uses edge cancellation. So if you cancel a task, what it means is that it gets scheduled with a cancelled error just once. If it decides to catch it and go on, then nothing happens. The task goes on as normal. Whereas with any I/O and Trio, if you cancel a task, the cancel scope containing a task, then whenever you await on something in a task, you get a cancelled error every time. Also by design. So that's it for the task groups. One thing that I forgot to mention, by the way, in exception groups is that since it's only available in Python 3.11, I made a handy-dandy backport, which works in earlier Python versions. Let's see some of the syntax here. Now, if I can just find the right project here. So it has this catch context manager that allows you to do pretty much the same as with except star, but you need to use callbacks. So this is how it works. So no except, but with catch. And then it takes as an argument a dictionary where you can have as keys the exception classes that you want to catch or a tuple of such. And then as values you will have the callback that is called instead of the except star block. So it should be pretty much the same. If it doesn't work the same way for any reason, then that's a bug. All right, I have nothing else. Thank you for listening.